Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS and we are focusing on ISS 2026. We have completed the topic econometrics of statistics paper 3 and we have started sampling techniques and we have completed almost systematic sampling. Today we'll do one PYQ on systematic sampling which came in 2019 and it is of 15 marks. So let us begin. The question says that why is the method of systematic sampling widely used in practice? Give practical examples. Show that systematic sampling is more precise than simple random sampling. What happens when the units have same positive correlation? So there are four parts in the question, and this is of 15 marks. This question is of 15 marks. From the question itself, first part says that why is systematic sampling widely used in the practice? I'm telling you the key points. It is, first of all, it represents whole population. As we all know that whole population is represented taking out the sample from it, and then there is randomness. First unit is selected randomly, so there is randomness in selection. Then it is efficient, more efficient than simple random sampling and stratified random sampling. Then again it is cost effective. And one more point you can write, that it is simple method, or it is widely used due to its simplicity. You can make sentences using these key points in the exam. There are I have told you 5 key points which are important one in this question. Then we have completed why is the method of systematic sampling widely used. Then give practical examples. Now what are the practical example? If we talk about, suppose, quality control. Quality control, you can say that in quality control, if we want to check the defects in the sample, then we can check every 100th item if we have 1000 items. So check every 100th item for defect in sample. Suppose the other example is market research. Suppose we have to take the interview take the research. Suppose we are researching on a specific product and we want to know the opinions of people in a shopping mall. So we can take interview of every fifth person entering the mall. And one more can be there. If we have to select suppose we have to select a student, selection of student. Suppose we have to select a student from the class of 50. So we have to select a student of 5 students from the class of 50. So we can take select every 10th student in the class. And similarly, you can form many more examples like this. Okay. So first part of the question is done. Then the second part is give practical examples. We have done this. Only three are enough. And then show systematic sampling is more precise than simple random sampling. Precision here means efficiency. So we know that variance of y bar simple random sampling is nothing but n minus small n upon n into s square. Here capital N is nothing but small n into k. So we can replace here nk minus n upon nkn s square. Taking out nk common, n common, we are left with k minus 1 upon nkn into s square. Here n and n get cancelled and we are left with variance of y bar simple random sampling is nothing but k minus 1 upon kn s square. Now variance of stratified systematic random sampling. Mean of systematic random sampling. Variance of mean of systematic random sampling we have derived in one of the lectures before when we have started the topic systematic sampling. So I'm writing it directly. There are two variances. We'll take the first one which we derived, which is n minus 1 upon capital N into 1 plus rho n minus 1. Here rho is nothing but correlation coefficient. So here also we can take nk minus 1 upon nk into 1 plus rho n minus 1. Now for relative efficiency, we can relative efficiency is nothing but variance of y bar simple random sampling upon variance of y bar systematic sampling. This is the variance. So we can substitute the value in relative efficiency. So variance of y bar systematic random sampling was k minus 1 upon nk into s square upon nk minus 1 upon nk into 1 plus rho n minus 1. Here s square is also there. S square. So this will be s square. The common terms will get cancelled out and we are left with k minus 1 upon nk minus 1 into 1 plus rho n minus 1. Now putting the value of rho as minus nk minus 1, 1 upon minus nk. If rho is equals to minus 1 upon nk minus 1, then relative efficiency is 1. And if rho is equals to 1, then relative efficiency is minus 1 upon nk minus 1. So the value of rho lies between minus 1 upon nk minus 1 and 1. So it depends on rho, the relative efficiency. If rho is greater than 0, or first of all, if rho is less than 0, if rho is greater than 0, and if rho is equal to 0. If rho is less than 0, then variance of y bar systematic is more efficient. Then variance of y bar simple random sampling. If rho is greater than 0, then variance of y bar systematic is less efficient than variance of y bar simple random sampling. And if it is equals to 0, then both are equally efficient. So we have shown that systematic sample is more precise than simple random sampling. And the next one is what happens when the units have same positive correlation. If the unit have same positive correlation, here the correlation is positive, correlation coefficient is greater than 0. If it has same positive correlation, then variance of y bar systematic is less efficient than variance of y bar simple random sampling. You just have to write this in the answer that it has due to rho greater than 0. Okay, let us do this. If correlation coefficient is greater than 0, then our relative efficiency was k minus 1 upon nk minus 1 into 1 plus 1 plus rho n minus 1. This was our relative efficiency. If this is equals to 0, relative efficiency is nothing but variance of y bar simple random sampling upon variance of y bar systematic sampling. So if it is the great, we'll multiply it on both sides. So variance of y bar simple random sampling into nk minus 1 and 1 plus rho n minus 1 is equals to k minus 1 into variance of y bar simple random sampling. If rho is greater than 0, then this whole will be greater than 0. Suppose rho equals to 1. So if we put 1 here, then we will get n variance of y bar simple random sampling n into nk minus 1 is equals to k minus 1 into variance of stratified simple random sampling. Systematic. So if rho is greater than 0, then this whole term would be greater than 0, this term. So we can say that variance of y bar simple random sampling is less than variance of y bar systematic random sampling, and hence we can say that systematic random sampling is less efficient than simple random sampling. This was the answer of the fourth part of the question. If they have positive correlation, then variance increases of systematic sample, and then systematic sample becomes less efficient than this simple random sampling. So this was the question of 2019. I hope you got the question, and if you still have any doubt, you can ask in the comment section or on WhatsApp channel. keep on doing it with consistency, and there are much more questions on systematic sampling, like similar to this and similar to the comparison that we have done in the class. You can attempt those. If you face any queries, then you can ask us. And keep on watching the lecture videos regularly, and uh, keep, we don't have to do just statistics. We have to focus on English and GS as well. So English class has been taken similar simultaneously with this statistics class, so I hope you are watching that as well. And keep on working hard. All the best. Thank you.